Hi everyone, so in today's video I wanted to speak a little bit more about fractions. Now again, I've mentioned fractions in previous videos and I will make sure I link them. I think it's up here in the corner. So today what I want to speak about are equivalent fractions, or basically any type of question where they ask you to simplify a fraction. And I will also speak about mixed numbers, because I had a couple of questions from people about mixed numbers. So first of all, equivalent fractions, or any type of question that asks you to simplify a fraction. So I'm gonna actually start with a couple of examples. So let's say I have 24 over 20. Now, if I put this one on a calculator, it will give me a specific answer. But there are other fractions that actually give me exactly the same answer. And also, in that case, that means all of the fractions that give me the same answer are equivalent fractions. Now, first of all, when we have to simplify a fraction and they tell us, look, I want this one fully simplified, that means you have to divide both the numerator, so that the top bit, and the denominator, the bottom bit, by the same numbers until you get to a situation where you can't actually divide by absolutely anything. So I'm gonna show you how we can do it with 24 over 20. Now, both 24 and 20 are even numbers. That means I can divide both of them by 2. So what I'm gonna do is I'm gonna divide the top one by 2, and I'm gonna divide the bottom one by 2 as well. So I've got 24 divided by 2, that is 12, over 20 divided by 2, that's 10. These two fractions are equivalent. They're actually the same. Now, I've got 12 and 10. You can still divide by 2 because they're both even. And we go to 6 and 5. And now, 6 and 5, I can't actually divide them by anything. That's me done. So you've got this, and this. They're all equivalent fractions. If we put them on the calculator, they will give me exactly the same thing. Now, obviously, we like to use smaller numbers. So most of the time, you're asked to simplify your fraction as much as possible, because working with 24 over 20 is a bit more time consuming and it's a bit more extra work than just 6 and 5. Now, very quickly, see how I divided by 2 and by 2? I could have, and I'm going to do it all over again, I could have be like, look, this 24 and this 20, they're both in the 4 times table. I can just divide by 4. Because it's, again, too time consuming to just be doing 2 and 2. And it gives me 6 over 5. And that's fine. So both of this method of simplifying are fine. So just play with it. Know your times table and make sure you try as many methods as possible until you get to like the fastest one. And as I wanted to say, we've got 24 over 20, 12 over 10, and 6 over 5 are equivalent fractions. They are exactly the same. Now, I've got another example because I feel like I want to play a bit, and let's get some bigger numbers this time. Let's get the 36 and 48. I can get the longer way and be like 36 and 48. They're both even numbers. I don't know any other timetables at the moment, so I'm just gonna divide by 2. And that gives me 18 over 24. I can follow on the same idea, even numbers, divide by 2. That gives me 9, and this gives me 12. Now, 9 and 12, they're not even. I can't divide by 2. Oh my goodness, panic all over the place. But if I can't, can I divide by 3? So now you thinking about 3 this time. I can divide both of them by 3. They're both in the 3 times table, so I get 3 over 4. Great, I've simplified my fraction. Well done me. But is there any way I can do it faster? Is there like any, yes, I want to do this a bit quicker because it just bothers me that it takes me so long to do this. So the first thing for me personally that I see is that 36 and 48 are in the 6 times table. So I can divide by 6. And I can be like, oh, this is 6 over 8. 6 over 8 are even. Divide by 2. Gives me 3 over 4. Great, we've got exactly the same answer. Perfect. But I can be like, when I look at 36 and 48, there's also a possibility that I can't divide by 6 because I don't remember the 6 times table. And that is understandable. So we could be like, oh, 36 is in the 4 times table because I know that one a bit better. So both of them are in the 4 times table. Perfection. 9 over 12. And then I divide by 3. I get 3 over 4. Perfect. Getting these 2 methods are like way shorter by far than the one I have on the top. Way less calculations. I'm way faster with all of this. Lovely. And obviously I can kind of play around. I could have divided by 2 and then by 6, or here I could have divided by 3 and then by 4, and it's just basically playing around, and I think it's fine. Or I can be like over the top and be like, oh, I feel so confident with all of these timetables and everything that I can just straight away see that this is divided by 12. Which is, wow, very good for you. Me personally, I wouldn't be able to just see straight away that it's divided by 12, but if you can see it, go for it. And it's actually quite interesting when you do it like that, because all of these fractions I have over here, they're all actually the same fraction. At the end of the day, they're all 3 over 4. So if I want to make a list of equivalent fractions in this case, it's a bit longer. So I've got 36 over 48, I've got 18 over 24, I've got 9 over 12, I've got 6 over 8, and I've got 3 over 4. So all of these ones are equivalent fractions. And it's interesting. And playing more with this one and trying to find different ways, I'm in the end gonna get more equivalent fractions, and that's quite cool from my point of view. So yeah, I mean, play as much as you want. There is no right or wrong answer, especially when it comes to simplifying. Use as many methods as you want to. I quite like trying to find as many as I can, and it just makes me feel kind of accomplished, and it helps me understand the whole topic a bit better when I play with all of these ones. But yeah, another question I had from a couple of people about fractions in general was mixed numbers. So I'm gonna do a bit about mixed numbers on the side here. So I'm going to do a bit about mixed numbers, and these are numbers, they're fractions that have are considered top heavy, which means the numerator is bigger than the denominator. I can still simplify something in the end. So this is something like the 6/5. I'll go over here, which is actually the first one I'm going to use. So if you think of a fraction, imagine I have a whole bit that I've split into 5 and I'm taking 6 parts of it. Now obviously I can't take 6 parts if I've split it into 5. So what that actually means by this means that I have one full and then I have a little bit. So let me explain, because let me draw something. So probably that did not make a lot of sense when I said it like that. So let's say I have this rectangle that I've split into 1, 2, 3, 4, 5 parts, and my fraction of there says I need 6 of them. So I've got the 1, the 2, the 3, the 4, and the 5, but it tells me there's another 1. So I actually have another little square completely outside of that to get 6 parts. So that's what it means. Now in this case, 6 of, so I have these ones. Now in this case, we can change this fraction into a mixed number. And the way we change it into a mixed number is we actually think about 6 divided by 5. So on the side over here, I'm going to do 6 divided by 5. Now, when I do 6 divided by 5, I need to think how many 5s go into 6. That's 1. But I also have a remainder. I have a remainder, and my remainder is 1. Now, very important how we write this. So we know 5 goes into 6 once, and we have a remainder of 1. Now, this goes in front of my fraction as a 1. And then I've got this little one on the top. That's my remainder on top of this. So this one tells me I have 1 whole and 1/5, which is exactly what I have here. 1 whole and 1/5. Now, I'm gonna give you another example that doesn't have 1 and 1, so it gets a bit confusing. So let's say I've got 7/5. So again, I do 7 divided by 5, which gives me 2, remainder, remainder 2. So in this case, I write it as a 1 and 2/5. So again, the 2 is the remainder, and then the 1 is the whole that goes in front. And that's why it's kind of called a mixed number, because I have a whole and a fraction, so it's a mixed number. Let's do another one. Kind of want to do a bigger one. What should I do? Okay, let's go with 17/7. So again, I'm thinking of 17 divided by 7. Now we need to be a bit careful. That is a 2. So go 2 times 7, that's 14. So what I'm doing next is 17 take away 14, and that gives me the 3. So this is the remainder. Great, so now I follow the same idea. I've got 2 wholes and 3/7. So that's the whole idea of the mixed numbers. That's the whole thing. And yeah, these were the only questions I actually received related to fractions. If you have any other questions related to fractions or how to do specific questions related to fractions, just let me know in the comments below and I will try to answer, or maybe do more videos like this. So yeah, have a lovely day and I will speak to you soon. Bye.